Hey guys, welcome to another easy LeetCode question. Today we're going to solve LeetCode 160, intersection of two linked lists. So this question gives you two singly linked lists, and those linked lists intersect at a certain node, and then you should find that node and return it. So I'm going to talk about three solutions. I'm going to talk about the brute force solution, I'm going to talk about the HashSet solution, and I'm also going to talk about the optimal solution. But for the code, I'll only do the code for the optimal solution, but I'll also upload the HashSet solution to the GitHub link, so check it out. Alright, so this question gives you two linked lists. Let's call them A and B. And as those two linked lists intersect at a certain node, let's call it, let's say this is node 9, and that's where those two linked lists intersect. So linked list A has nodes 1, 3, 7, 9, 11. Linked list B has nodes 2, 4, 9, and 11. So how do we solve this question? First of all, let's talk about the brute force solution. The brute force solution is quite trivial, actually. So what you can do is you can have two loops, and then you go through the first loop, and for every node, you look for its equivalence in the second loop. So let's do that. Let's say we go through linked list A as the parent list, and then we're at node 1, and then we check for node 1 in the second linked list. It's not there, so we go to node 2, check for it, it's not there, we go to node 3, that's 7. We check for it, it's not there, and then we get to node 9, and then we check for it, and it's there. So we return node 9. So this solution is going to run in O of A times B time, because we're doing two for loops inside each other, where A is the number of nodes in linked list A, and then B is the length of linked list B, number of nodes in linked list B. So how about the HashSet solution? So the HashSet solution is also optimal, but it uses extra space, and then we don't want that, right? So what the HashSet solution does is you go through one list, let's say linked list A, it can be any one of them. You go through one list, you traverse through the list, and then add all the nodes in that list to a hash set for a constant lookup. So let's do that. Let's say we went through linked list A, and then we added nodes 1, 3, 7, 9, 11 to a hash set. And then what we do after that is we go through all the nodes in linked list B in a second loop, and then check if we've seen that node and the nodes in linked list A. So let's do that. We go through 2, we check in the hash set, is 2 in the hash set, no it's not. We go to 4, is 4 in the hash set, no it's not. We go to 9, is 9 in the hash set, yes it is. So what's the time and space complexity of this algorithm? So for time complexity, we're running in O of A plus B time, because we're going through all the nodes in linked list A, and after that we go through all the nodes in linked list B at most. So that would be O of A plus B time. And then for for space complexity, we're going through O of N. That's we're storing all the nodes in one list. So that would be, let's say, if we're storing all the nodes in linked list A, that's O of A space, right? So that's that. But then we don't want extra space. We want to do this in optimal O of 1 space, and maybe O of A plus B time. So if we look at both linked lists, right, they're not the same length. They can be the same length. In that case, it's very easy to solve, because you can go through both linked lists in tandem, and then check when one node is equal to each other. But then you are not guaranteed that those two linked lists would be of the same length. So if we look at linked list A, it has a length of 1, 2, 3, 4, 5 nodes, and then linked list B has a length of 1, 2, 3, 4 nodes. So linked list A is has one node more than linked list B. So what we have to do is to determine the difference of the two nodes, and then when we find that difference, we can move the longer node, the linked list with more nodes, to that difference, and then traverse both lists in tandem until we get to the node that intersects. Okay, let's just say we had another node there. And then if these two nodes were of the same length, it would be quite easy to just go through both lists in tandem. So when we're here, we check is this equal to this? No, it's not. We're here, we check is this equal to this? It's not. We're here, this equal to this? No. And then we're here, and they overlap. And then we return this node. For this case, when both linked lists are not of the same length, we have to move the pointer for linked list A to the difference of the two nodes. So we're going to use two pointers. One pointer is going to be initialized at linked list A, the head of linked list A, and another pointer is going to be initialized at the head of linked list B. And then we traverse both lists in different for loops or while loops, whichever works for you. And then we find the length of both lists. So we're going to find the length of linked list A to be 5. I'm going to write that down. And then we find the length of linked list B. Oh, that's not 5. And then we find the length of linked list B to be 4. And then we get the difference of that, which would be 1. And then we determine which one of those linked lists is longer. So linked list A is definitely longer. So we move the pointer of linked list A one node in front. So now pointer of linked list A is here. And then we get to the pointer for linked list B. We move it to the head of linked list B since it's the shorter node. And then we traverse both lists in tandem until we get to a point that they overlap. So we're at 3. Is 3 equal to 2? No, it's not. 7 and 4. Do they overlap? No, they do not. And then we get to 9. Do they overlap? Yes, they do. And then we return it. So in that case, we're not going to use extra space, which is amazing, but then we're doing a couple bit of for loops. But depending on the way you implement your algorithm, you can have it run in O of A plus B time. That's by going through all the nodes in linked list A and then going through all the nodes in linked list B. So that's the optimal solution. For tradition's sake, I'm just going to write the time and space complexity, and then we'll go straight into the code. So for time complexity, we're running in O of A plus B time, and for space complexity, we're running in O of 1 space. Awesome. So let's dive right into the code for the optimal solution. Alrighty, so first we get the length of the two linked lists. So we have a list node. I'll call this one L1. And then we have another list node, L2. We set L1 to head A, and then we set L2 to head B. And then we have an int for len1. That's the length of the first linked list. That's L1. Set it, initialize it to 0. And we have another len2, initialized to 0. And then we get the length of list 1. So while L1 is not equal to null, L1 equals L1.next. And then we increment len1. And then we do the same thing for L2. So now that we have the length of the two lists, we can calculate the difference. So first of all, we have to determine which list is longer. So say if L1 is greater than L2, this means that list 1 is longer. So if list 1 is longer, we have to use the pointer that we're going to use in the second iteration, x places, x representing the difference, in front. So first of all, let's calculate the difference. Let's call it diff. Diff is equal to len1 minus len2. And then we move L1 diff places in front. But now we first of all have to set L1 to head A, so I'm just going to use head A instead. So I'm going to use a for loop. I is equal to 0, I is less than diff, I plus plus. And then we can set head A is equal to head A.next. And then we do the same thing in the case where list 2 is longer. So we calculate the difference. This time it's going to be len2 minus len1. And then we set head B is equal to head B.next. Awesome. So now that we have taken care of the difference, we have to move both nodes in tandem, both pointers in tandem, until they intersect. So how do we do that? after this if statement, we have to say while head A is not equal to head B, head A equals head A to next, and then we do the same thing for head B equals head B dot next. So that is pretty much it. Now, when this loop breaks, we're sure that head A and head B are the same, they overlap. So now we can return either one of them. So I'm going to choose to return the first one. So return head A. And I guess that's it. I'm just going to make sure that we have everything. I always have errors, so I'm just going to go for it and then run code. Oh, cool. It's accepted. I'm going to submit. Yeah, that's it. And it's faster than almost all the submissions for Java for this question. Now you see these are the other two solutions. I think this one is the one I did in February. It's the one for the HashSet solution, but it's not as optimal as this guy right here, as the one we just did. And yeah, I'll include the code for that in GitHub also. So thanks for watching. If you like this type of content, please consider subscribing to the channel, and then like this video for the YouTube algorithm, share it around the community, and comment down below if you have something to say, and I'll see you in the next video. Bye bye.